Hello everyone. Greetings everybody, and welcome back. Um, so thank you for tuning in. So in the previous lesson, lesson 3, so we did the last type of contact force. We discussed the normal force, which was the last type of contact force that we're going to discuss. So now in lesson 4, which is this lesson. So welcome to lesson 4. So now for lesson 4, we're going to begin with non-contact forces. Okay. So this is non-contact. Okay. Or you can say field forces. Non-contact or field forces. Field forces. So it's non-contact or field forces. So now, so what is this? What is a field? Okay. A field is a region in space where an object or some where an object. So an object with certain properties. With certain properties will experience a force. Will experience a force. So now field forces. Field forces are non-contact forces. Non-contact forces. So again, what are non-contact forces? Okay, we need to know that. So non-contact forces. Non-contact forces are forces which act over a distance. Okay, they are forces which act over a distance. A distance. So they do not have to be touching. So it's unlike the previous types that we discussed. Okay. All the previous types of forces were contact forces, isn't it? So it means they needed to be touching. So in this case, they do not have to be touching. Okay, so they are non-contact. That's why we say they are non-contact. Okay, and so there is a field which they act in. Okay, so there are three most common um, examples of fields. Okay, the most common examples of fields are as follows. Okay, so they are as follows. The first one is gravitational field. Gravitational field, magnetic field, magnetic field, and electric field. And electric field. Okay, so we will start. So let us discuss the first type of field. Okay, the gravitational field produces gravitational forces. Okay, so in this case, you will find gravitational forces. And then magnetic fields produces, oh, magnetic forces, sorry. They produce magnetic forces. And then electric field produces electrostatic forces. So, okay. Now, okay, let us not waste any time. Let's get into the first one. Okay, the gravitational field, which produces gravitational forces. Okay, so let's talk about the first type. Okay, gravitational forces. Gravitational forces. Gravitational forces. So, what are gravitational forces? Okay, so we begin by defining. Okay, this is the force. What is a gravitational force? Okay, this is the force which causes things to fall down. To fall down towards the earth. Okay, and prevents us from falling off the planet. So a further explanation here. Gravitational forces. Gravitational forces exist between any two objects with mass and volume. Okay, with mass and so it's mass and volume, and they are forces of attraction. Or you can say pull. And then the two very important points here. Okay, let me make bullets, okay? So this is an alternative definition, okay? Gravitational force is a force that attracts objects with mass towards each other. Then another very important point here. Any object with mass exerts a force on any other object, with mass. So it's important to know this. So, okay. And then how does it relate to the Earth, okay? So the Earth is gravitational force. The Earth's gravitational force pulls everything. Pulls everything down towards the center of the Earth. Which is why when you drop an object, like a book or an apple, it falls to the ground. So it pulls everything towards the center. Okay? So that's why objects fall to the ground. It's because of the gravitational force. So you can imagine that around the Earth, okay, and try to draw a circle here. Around the Earth, so this is the Earth here, and this is the Earth. This is Africa here. Then there is Madagascar there. Then there is Asia. And then there is America. So you can imagine that around the Earth, there is a gravitational field, and all the objects are being pulled towards the center of the Earth. Okay? So the gravitational force is acting towards the center of the Earth, like that. So this is how the gravitational field looks around globe, the planet Earth. Okay? So another important point here to know is how it relates to the distance and the mass of the object. So the mass and the distance between the two objects, okay, have an effect on the gravitational force. So we say what? The greater the mass, of the object, so the greater the mass of the object, the stronger the gravitational force. The stronger the gravitational force. the stronger the gravitational force of attraction between them. So, okay, and then with regards to distance, okay, with regards to distance, we say the closer, okay, the closer objects are to each other, the stronger the gravitational force. So the gravitational force is strong if the objects are close to each other. Force between them. Closer objects, the stronger the gravitational force. Okay, so it means the further the objects are, okay, the further the objects are to each other, the weaker the gravitational force. Okay, that would be the opposite of this point here. So again, even the first point, the greater the mass of the objects, the stronger the gravitational force. Stronger the gravitational force. So it means the lesser the mass, the lesser, if we have the lesser the mass, it means we would have the weaker. It means in this case here, we would have the weaker the gravitational force. It would be the opposite of the statement that we have here. You see? And then what else do we need to know? Okay. The other thing that we need to know out here is so what we need to know here is that what mass of an object mass of an object is measured in kilograms kg, and it is independent independent of place where where it is being measured. So unlike weight, okay, unlike weight, so weight. So now weight of an object is measured in Newton. Is measured in Newton. And it changes depending on where it is being measured. So it changes depending on where it is being measured. So what does that mean? It means that if you measure weight on Earth, it won't be the same weight on the moon or on the other planet. So the weight changes depending on where it is being measured. It depends on where you measure it. Okay, so and then the other thing is free fall. Okay, so what is free fall? So we say objects are in free fall. Free fall is the key word here. Okay. When the only force acting on them is the gravitational force. Is the gravitational force. So now, okay, weight. Okay, weight has a formula. Okay, weight, which we denote by W, it has a formula and it can be calculated. It's calculated. So weight is calculated by multiplying the mass of an object. So the mass m. Okay, so we denote the mass with a small letter m. So by multiplying the mass m of an object, by the gravitational acceleration. So gravitational acceleration is g. Okay, small letter again. So the formula is W equals to m multiplied by g. Okay, so this g is the one that changes when measured at different places. Okay, so g is 9.8. Okay, on Earth. G is 9.8 on Earth. Okay, it's 9.8 when you're on Earth, but it changes when we go somewhere else. Meaning that, for example, if we're on the moon, it is no longer 9.8, it's something else. Okay, so that's what changes the weight here. That's what makes the weight to change. This is G here. This is G. Sorry about that. So it's M multiplied by G, small letter G. Okay. So, okay. Let's leave it here for lesson 4. Okay. Let's leave it here for lesson 4. And thank you for tuning in again. And leave your questions in the comments, guys. Okay. So in the other lessons, so I will talk about the other types of fields, right? And the other types of forces that comes with them. Okay. In this case, we talked about the gravitational field only. And what comes with the gravitational field is gravitational forces. Okay. So we have not yet talked about the magnetic field and the electric field. And we will discuss them in the next lesson, in lesson 5. Okay. So I hope you tune in lesson 5. And so we will do some more on non-contact or field forces. Goodbye for now and take care and keep studying, okay? Study hard. Bye-bye.